We are pleased to welcome Professor Anant Agarwal, who specializes in applied Gen AI at TrueFoundry, a leading cloud-native LLM Ops and ML Ops platform. He previously led the AI and ML team at Nissan, solving key business problems using machine learning and earning the Best Manager Award. An alumnus of the Doon School, IIT Kharagpur, and ISB Hyderabad, he has judged Altair's Global Enlighten Award thrice and conducted workshops for leading institutions worldwide. We are thrilled to have him with us today to share insights on how AI is transforming the professional landscape and empowering individuals to shape their careers from the classroom to the corporate world.
All right, so let's get started. So I think today's session is about how do you map your career from classroom to corporate. And if you have attended the last three sessions or the first three sessions, you would already have gained a good sense of what is AI, demystifying AI, how do you build your first ML model, and so on. So in this session, what we will do is we will understand how do you map your career, right? So learning is an ongoing journey, right, throughout your life. But in a classroom or a program setting, an end goal is also to get to the next stage of your career. So what we'll do is we'll start with what it takes, what it means to be industry ready, how you can do it, right? What are the steps involved? What are the key tips involved in how you can actually make that leap from classroom to corporate? How I did it, I'll also share my journey briefly towards the end. And hopefully all of this can help you feel that you will be in a good position once you go through this session. You actually know what are the things which are not really talked about, and which are only available in conversations between people who have actually been there and done that. So let's start with what it takes to be industry ready in the field of AI. Now, one thing before we start is, if you think about AI, and you might have read it somewhere, a few taglines, right? AI is the one of the hottest jobs of the 21st century. It is a unicorn field, right? And you might have heard a lot of buzz around it. So what I'll do shortly is I want to decode a bit of the buzz and actually lay down very, very, very low level what it really means to build AI. Because as if you're entering this field, you will likely be building AI systems. So firstly, you might have seen this diagram, and when you think about AI being a unicorn field, unicorn is nothing but a term which depicts that it's not one or two or three things that you need to know to build AI. You need to know a multitude of things which actually enable you to build AI. And how we think typically, how it's introduced is basically this Venn diagram where you need to know computer science, you need to basically be able to program something, you need to have maths and statistics background or know the maths and statistics behind the algorithms, right? Because eventually when you're building AI, it's learning from some data, and statistics is the science of data, and obviously maths is there because algorithms are mathematical in nature. And obviously you're doing this for some business goal. It's not a computer science goal or a math goal. You're not a researcher when you're doing AI, right? Typically you're building it for some business expertise, or you need to have some domain expertise. Even let's say you're in medical science, you're a researcher, you're doing it for medical science, right? You're not just doing it for the sake of the algorithm itself, likely, like 90% of the times. So this basically depicts that, okay, data science is somewhere in the middle, or you can even call it AI, right, loosely speaking. And this is what we think when we say that AI is a unicorn field, right? You need to know computer science. You also need to know mathematics, right? You cannot just be a computer scientist, BTech, and do AI. You can't do that. And you also need to have some appreciation of the business domain as well, business or the domain. So let's, while we walk through the session, let's understand how you build it. But before that, I want to actually break it down into the real picture that an industry person would actually, break it down as. So let me break it down into three things. And I will specifically talk about the tech stack you need to know to actually build AI systems. And this is the ideal unicorn, right? This is the stretch goal that you can think of in your career. This is what you want to basically be able to know, right? Either manage or build. So I'll talk about the tech stack, and this is a lot of tech stack, right? But fundamentally, you need to know Python, which is the fundamental programming language that's taking off. And a lot of integrations or libraries for building AI systems are using Python. But however, in terms of if you're doing statistical models specifically, R is also a very strong competitor. So R has a lot of algorithms which are not there in Python. You also need to know PostgreSQL, or basically SQL language, right? Which is used to query databases, right? So you can only do AI if you can get the data firsthand, and data typically resides in databases. And finally, Bash is one more language that you need to know, which is a command line language. And why I'm saying Bash and why am I putting it along with AI is because Bash is your first stop. If you even want to do any data analysis, you can do some commands like grep, cat, and a lot of fast commands in Bash before actually launching any Python notebook. So some data wrangling is possible in Bash, and Bash is generally a good script to know. Then we come to package management. So let's say you know programming languages. You also need to be able to download and set up your environment, which is basically the domain of package management. Package, I mean any specific library that is allowing you to do certain things, right? So you have pip, which is the most popular one. But 𝘬𝑚l is a very strong contender, and 𝘬𝑚l is something which is new, right? Which is slowly, no, not slowly, which is very quickly becoming industry standard. And 𝘬𝑚l is very fast. So what happens is, just to give you a sense of why is 𝘬𝑚l becoming the industry standard and why is pip, not that fast compared to 𝘬𝑚l, is 𝘬𝑚l does the package resolution very efficiently. What that means is, let's say you want to download package 1. Now, to download package 1, you actually need, let's say, 10 other packages to be installed first, and then only package 1 is successfully installed, right? So with pip, what happens is all of this figuring out that to install package 1, I need these 10 packages. To install another package, I need another set of packages. This is done on the go when you're actually typing the command to do the package installation. But with 𝘬𝑚l, this is already figured out. The way 𝘬𝑚l works is it creates a log file, and all of this, dependencies are already figured out. So at the installation time, it's super fast. Right, so this is something good to know about. And then obviously you have the Anaconda distribution, which is like all the packages, popular packages for data science as part of a distribution. Now coming to, let's say you have set up your environment. Now what next? Now, typically as a data scientist, if you're already a data scientist, you would be working a lot with Jupyter notebooks, launching them, experimenting, building models, and so on. But nowadays, if you have heard about Cursor is an IDE which has agents integrated, and which actually satisfies the term vibe coding. Because let's say you have written a piece of code either in a notebook or as a script, and what Cursor allows you to do, obviously there is a free limit. You can do vibe coding. You can say that, okay, fix my code, I want to implement this, and then it automatically does that in your code. It changes your code. Obviously ask after your approval. So Cursor is a very nice IDE built on top of VS Code. And then for R specifically, you have RStudio. Okay. So now this is the foundational stack. Before now what we'll do is we'll start understanding some of the libraries, right? So let's say you have all of this in place. Now, for scientific computing, the very basics you need to know is NumPy. SciPy is for scientific Python. Then for data wrangling, there is Pandas. But what a lot of people do not know about, right, and which is slowly becoming the industry standard, is Pandas is not that fast, right? Because remember, in industry applications, speed is very important. It's not about just getting the result. It's about how efficiently, how fast you can get it, and whether it's reproducible also or not, right? So if you do the same thing 10 times, you should get the same result. That is also of utmost importance. So Polars is becoming a very powerful alternative to Pandas. Polars is extremely fast, right? It's built on top of Rust. So it's a very, very fast package. Then for data visualization, Matplotlib is the very basic one, right, which came a long time ago. Seamon has very nice visuals, right? So with Seamon, you can actually get very, very nice colors, visualizations, and types of charts. Plotly is for interactive plotting. And there is one more, which is my favorite, which is for machine learning visualization, which is called YellowBrick. Right? Again, a lot of people do not know this, but this is a very nice library. And then you have done, so far what we have done is we have understood how to set up environment, how to do the basics of scientific computing, data setup and exploration. Now coming to statistics ML, you have stats models, you have scikit-learn, and finally with R, you have tidy models to do all of, a lot of these things. So tidy models is a kind of a distribution which has a lot of things available. And I'm just covering the foundational aspects of, the things that you typically need to work together with, or you need to know the foundational knowledge of to even crack interviews, right? A lot of like Python syntax would be called out. You need to understand what is a distribution. You need to understand the basics of NumPy, right? Even though you would never use NumPy when building, let's say, a model, it's still fundamental knowledge. So you need to know it, right? And if you can demonstrate, polars, right, instead of pandas, or in addition to pandas, that's a brownie point, right? That's the whole point of discussing this tech stack, that you get a sense of, there's a lot of things involved. And I've just covered foundational. Now, with foundational, what you're able to do is you're able to do statistics and you're able to do machine learning. But there is a very big caveat and an eye-opener which comes to people when they join the industry. They have learned machine learning, they have done a lot of things, right? But you need to be specialized. So I'll talk more about this, but specialization is very important. And that's typically covered in a good PGP program. So if you look at deep learning PyTorch was developed by Facebook. It's a very nice library to learn. There is TensorFlow, which is by Google, right? Which is again an industry favorite. And there is one more library which is a bit niche called Pyro, which is for deep probabilistic programming, right? So all the PyTorch and TensorFlow are good. They are not probabilistic in nature. They cannot enable you to do deep probabilistic programming. And there are applications for that. So Pyro is a very nice framework, to do that. Then if you are getting into NLP, right? Let's talk about NLP. There are some core packages like GenSim, which enables topic modeling. There is Beautiful Soup, right, for XML parsing. When you're scraping websites, how do you get the data in a proper format so that you can build some AI systems on top of it? And you have Hugging Face, which has a nice ecosystem of NLP models, nowadays LLM models, right? And a lot of ecosystem around that is with Hugging Face. And there is Selenium as well, which is not a very core AI stack, but this is for web scraping browser data, let's say, or web data. So it is basically an automation framework where you can define certain things and it will automatically navigate different web pages, click and do different things. So I've included this in NLP. Then I will just cover some other specialized fields, like computer vision is one, right? Which is basically, can you take an image and build an AI on top of that, right? For example, face recognition. That falls under the field of computer vision. Similarly, optimization, time series analysis, causal inference, right? So computer vision, you have OpenCV, which is, very specific to computer vision. You cannot do everything with just deep learning libraries, right? If you're specializing in computer vision, you need to know OpenCV to do some pre-processing of the image. For time series analysis, right? Stats models is kind of for statistics and time series by extension, right? For time series analysis, 𝘔𝘂 has, quickly emerged as an industry and even an academic leading framework. And a lot of people do not know about 𝘔𝘂 yet. But if you see and if you follow the latest research out there, the latest implementations by leading people around the world, and even this is one of the frameworks that I've taught in one of my courses at Geo Institute in time series analysis. This is a very, very fast framework and very, very robust framework. A lot of every algorithm almost in time series is under this framework, right? So you talk about R algorithms, or even talk about like very niche algorithms in research papers. Then in optimization, you have J-Roby, right, which is an industry solver, but which is not free, right? You have to buy a license. But alternatively, there is Pulp, which is again open source, right? So open source basically means you do not need to buy it; it's free. And then causal inference, you have 𝑑𝑦, right? So causal inference is different from ML, and that's another something else you need to keep in mind when you're thinking about data science and AI as a field, right? And I'm talking about specific specializations right now. So the thing with all of these specializations is they are unique. They are different from ML, right? And ML is itself a vast field. Okay, so there are a lot of specializations that you can really take and you can really dive into. And then obviously there is generative AI, which is really taking off. And a lot of these frameworks are very new, right? 1 or 2 years max, right? So LangChain, I think, was about, it has already completed 3 years, right? But a lot of the developments and the new releases are still happening. So you have LangChain, LangGraph, LangSmith. LangGraph is for agents. You have llama-index, right? Why am I keeping this here? Because llama-index is very good for RAG applications. Although you can do RAG with these three, with the LangChain ecosystem, llama-index has more low-level implementations, and then a lot of other things, right? Chroma is a vector DB. Let me just skip some of these, but I want to talk about this middle one, which is MCP, right? So MCP is really taking off since November 2024, right? So just think about it. It's 11 months old, and the industry is already moving towards MCP, right? And a lot of implementations are occurring in MCP. Now, I just want to give you a sense of why this is, interesting, because if you had studied AI 8 years back, right, you will never have, heard the term MCP, or even 2 years back for that matter. So just to get a sense of how fast the field is evolving, you need to keep on top of frameworks, and not only frameworks, the conceptual parts of what problem it is solving. And you need to be able to be agile and learn the frameworks easily, right? So you need to have that foundational mindset in order to pick things very quickly. Then let's talk about some frontier things. And in frontier, what I've done is I've included the MLOps part of it, right? So typically as a data scientist, even in an academic setting or in a classroom setting, you have learned things, you get the results. But in a corporate setting, that's not enough, right? And you need to be able to put things in production, right? So there are a couple of things involved in that. The first thing is you need to be very familiar with cloud infrastructure, right? So cloud, like hyperscalers like AWS, GCP, Azure, pick any one of them. So here I've just picked Amazon SageMaker. You can also take Vertex AI in the case of GCP, and so on. So first thing is experimentation and tracking. So experiment on Amazon SageMaker. You can use MLflow for experiment tracking, right? Experiment tracking is basically, I ran one, fine-tuning job on a random forest model. My accuracy was 90%. I ran another one, it was 92%. So you are running multiple iterations. Typically, you're changing some data, you're changing some features, right? You're doing some feature engineering in an iteration. So all of that experimentation and tracking needs to be there for an industrial grade application. And then obviously you need to be very familiar with Git, which is for version control, right? And you can also do CI/CD with GitHub Actions. Okay, so you have done this. Now what? Now you have to actually create APIs, right? So your code will never sit in Jupyter notebooks always, right? And that's, I think, 80% of the data scientists, roughly speaking, right, typically just are very familiar with Jupyter notebooks, especially when you're starting out and you have not seen the industry, right? So the bottom row are tools which you need to be able to do, right? So API creation is important. Flask is one framework, right? It is a web server framework. You have Django as well, which is another little bit more involved and more complex framework. So if you know Flask, you're good enough. And Fast API is an asynchronous framework, right? So it's different from Flask in the sense that, simply put, it's very good for agents, right? So if you want to expose your agent or your MCP server as an API, right, and you want to be able to handle asynchronous calls, Fast API is good. And then you have Postman for testing. Then for packaging, you have Docker, and UI prototyping, you have Streamlit Radio. And some complementary stack is MongoDB and Apache Spark. MongoDB is distributed data systems, right? So it's basically a NoSQL database. Unlike SQL, which is like relational database, this is like NoSQL database. And Apache Spark is like for distributed computing, right? This is basically the field of big data, right? And these are complementary sets in addition to the core AI that we talk about. In enterprises, as a data scientist, you might need to know this, right? So you need to look into the job description and see, are they asking for Python or are they asking for MongoDB, right? And they are two completely different things. So why I'm talking about this is because you need to be very particular about what are you going to do in AI, right? And that's how you land your corporate job. And if you're now looking at all of this, you'll see that this is what makes AI a unicorn field, right? One part of it, at least the tooling part of it, right? The other part is obviously the depth of it, right? There's a lot of depth in the AI concepts. Now let's move forward. Now, what do you need actually to, kind of get into corporate very easily, get your first job or improve your existing job in AI? The mindset has to be shifted. What I mean by that is, in an academic setting, or even when you're learning, or you're a researcher, right, or you have done some AI, you have used AI for some undergraduate work, right, or even in your school or a pet project, your focus has been on the novelty part of it, right? How unique is your solution, right? What algorithm are you using? That's what excites us. But in a corporate project, actually, that's not, that important. It's important, and this is just representative by the fact, by the way. So this can be 4 or even 7, but it's not the main thing. What the main thing is, how production ready it is, right? And we'll talk about this when I'm talking about interviewing, how to prepare for your interview shortly, that you need to be production ready, right? You need to demonstrate that you do not only know how to build the AI system, you also know how to productionize it. And that's almost as it's super important in a corporate setting, right? Not so much in an academic setting, because as long as you understand the algorithm, build it and put it on top of the data, get nice results, fine tune it and report it, you're done, right? But in a corporate setting, it doesn't stop there. Why? Because once you report it, it only gets approved to go forward in a corporate setting, right? And the way forward after that is where basically 80% of the projects kind of fail, right? And when I say fail, they are not efficient. They do not have the necessary checks in place to, make a long-term run, right? So they probably run for 3 months, accuracies are not improving, or accuracies go down and they stop, right? So by fail, I do not mean that any tech is failing. It is just that the value proposition of that AI project is failing down the line, right? That's one of the ways to look at it. And why is this important? Why is production important? Think about it. In the corporate setting, what matters? So if you're putting AI in production, like properly, it improves your business outcomes, right? Most likely, not always, obviously, but most likely, right? And that eventually leads to a higher bottom line, right? So you're getting higher profits. And that's what people actually, the leadership cares about, right? They do not just care about what cool technique you're using. They also care about the outcomes. So now let's talk about how can you do it. First thing is, in a classroom setting, you need to be able to master the fundamentals. And again, you might have heard this throughout your life, right? Fundamentals are very important. And this is a very, very simple thing. But in terms of AI ML, these are very often overlooked. And that is why classroom learning is important, right? And I always recommend students, when they are coming to learn AI, to go through a rigorous classroom learning as well, right? So my personal suggestion is always to take a top-down approach. You get your hands dirty, but that is not enough. You need to be able to learn the first principles of AI ML. What this involves, right? Foundational subjects like probability statistics, things you are doing since 11th grade or in undergraduate, right? Like I did, I took probability statistics in my undergraduate, first postgraduate, even second postgraduate, and then in an MBA, right? So I learned it 3 or 4 times, right? Every time from a slightly different perspective, because first time was engineering, so it was very math heavy. The second time was in my postgraduate, which was a little bit more implementations and more depth of the theory, right? And in the MBA, it was all practical, right? A little bit on the surface, but a bit tricky still. DSA is data structures algorithms, Python, obviously, and linear algebra, right? And now typically people say, and I also had this question, why are these important, right? Why are these foundational? How will this matter? Because remember I talked about Pyro being a deep probabilistic programming language, right? So probability plays a very strong role. You need to master the fundamentals. Similarly, in linear algebra, deep learning is a very, very important area where linear algebra becomes a foundation, because you're dealing with neural networks, and your neural network is what? It's a set of parameters, right? Parameters are nothing but numbers. But if you have like, let's say your GPT 3.5 had 175 billion parameters, right? How do you put those parameters in matrices? And for matrices, you need to understand linear algebra. That's a very simple analogy. Core subjects like machine learning, time series analysis, which is often, and I'm saying very often, overlooked in classroom, or even when you're doing online setting. But in an industry, time series is very important because your data is time indexed, right? It's not always just, normal non-time series data. So this is very important. Forecasting, think about that, sales forecasting and so on. Relational DBs and data visualization, and then advanced subjects. Now, some tips I have here is try to implement almost every concept that you learn in class by scratch. And what this does is it gives you a clarity of what you are learning. Because remember, if you cannot implement things in AI, it's not AI, right? It's just some fancy concept you have out there. So you need to tie it, even if it is like, one or two lines of code, or it's very, very simplistic. It always needs to have a implementation. And what this does is it helps you prepare for coding interviews and even for your conceptual interviews, right? So your coding becomes good. So this is very important. Ask intelligent questions in class, right? But come prepared for some deep discussions. And where is this important, right? If you're applying for, let's say, one of the nice jobs out there in Amazon, which is an applied scientist job, right? Surface level interviews will not take you there, or surface level knowledge. They typically dive a lot into the math and the concept behind it. So if your target is like FANG, right? You need to be able to understand what is happening with the algorithm, right? How is that algorithm working? Okay, so you put a scikit-learn, random forest, your result is there, but that's nothing, right? You need to understand how it's working, why it's working, and finally build your thought leadership in the class, right? And when I say this, how it helps you is at work. Think about a life of a data scientist. What's happening is you're given a data, a business team has given you a data, they've asked you to do something, build a predictive model. And then what happens is you do not do everything yourself. You sit down with your team, right? Your peers or your seniors, whoever, and you think and discuss that, right? So if you're building a thought leadership in the class, either by doing good projects, taking them seriously, or even asking intelligent questions to the instructor, it prepares you for these kind of discussions, right? It's a very nice way to do it. Okay, so this is about classroom learning, master the fundamentals. And I will give you one example where, this is very important. So I actually took a lot of interviews at my previous role at a Fortune 500 company. And this was a question I put to a JEE AIR All India rank less than 100 candidate in an interview. So he was a very strong candidate on profile. There are a lot of nice things, obviously. Top 100 rank All India is no joke. But this simple question took a lot of time, right? More than expected, at least. What I would have expected him is to just look at it and just say, okay, maximum 20 seconds that, okay, this is the answer. But it took about 1 minute or so. And he was thinking a lot on this. And this is the question, right? So you can take a shot at this. There are two scenarios. The first scenario, you have a scatter plot where, or you have basically data points. So you have here 6 data points, each with 2 attributes, X and Y. And the way the data is that, it's following a linear relationship. It's all the data points are falling on the line and the slope is 6, y is equal to 6x. Similarly, you have another data set, right, with another 2 attributes, right? Think of this as y2 and x2 with 6 data points, but now the slope is y is equal to 8x. The question is, which of these have a higher correlation between y and x, right? So if x increases by 1, here you see a larger jump, but here you see a smaller jump. And my question basically was, and generally is in interviews, is which has a higher correlation. So give it a thought. I'll pause for 5 seconds and let's see if you're able to answer this. And just keep the answer with yourself, right? Okay, so if it's not jumping out at you, it's very simple. Slope does not have a correlation with correlation, right? So slope does not matter basically. And these are all, both of these are perfect linear relationships, right? So both have a perfect correlation of 1. And if you think about correlation, it's, if I go back to, where it falls under all of this, correlation is probably the first thing you actually learn in statistics, right? It's a statistical concept in the foundational. But if you overlook that, that could be your failure point, right? And that's typically one of the ways I judge my candidates is, are they able to answer very fundamental questions? What is central limit theorem, right? If you know the fanciest generative AI model and you are able to explain transformers to me, but you do not know central limit theorem, I cannot hire you because in my company, a lot of problems we are solving are not cutting edge transformer problems, right? We do not have that much data. We do not have that much budget for that compute. We have simple problems. So we need to do statistics as well. Right? And that is the context you need to keep in mind when you're learning AI, right? You need to keep in mind what is needed for me in the corporate setting and how do I best prepare myself for that. And on the side, obviously, you need to have fun, learn good techniques out there. Okay. So this is about classroom learning. Another thing is going beyond, right? So it's not enough to do classroom learning. That's not enough. And I want to talk about Google's 20% rule, which they implemented in the workplace. How Google actually came up with Google Chrome, AdSense, which is one of the largest, technologies out there for their advertising business. And what they said is spend 20% of your time regularly learning new skills. And they also measured and enforced this kind of informally. How you can do this? Acquire skills outside the syllabus by reading technical articles. There are a lot of these, right? I have links here towards data science, daily dose of data science, which is a very nice article, which implementations, analytics vidya, or even take short courses wherever necessary. And I'm saying wherever necessary, right? And I'll come to certifications part shortly. This is Udemy and YouTube, right? And YouTube has a lot of nice content, right? 𝘕𝘂𝘋𝘚, who was once the director of AI at Tesla and is a leading name in the industry, right, is talking a lot about generative AI on YouTube. Similarly, there are a lot of other people who are very well recognized who have taken to YouTube and are actually teaching nice things there, right? And Udemy is for skills, hands-on things you want to learn, right? And you don't learn it in a classroom setting always, right? It's because classrooms are variable, depends a lot. So if you want to learn something, if your project or the job description is asking you for a certain skill, you can quickly go to Udemy and learn that, right? Stay up to date with AI applications, right? How is AI actually getting applied? And you need to develop that for a business expertise, right? Because it's not enough to just know technical aspects. In an interview, you also need to demonstrate that you actually understand the problem statement. Because if you're only a tech geek and you only know the code and the math aspect of it, remember, you will lose out. So read TechCrunch, read The Batch, read Analytics India magazine for that. And then obviously read industry leading blogs, which are technical and non-technical both, like Google, DeepMind, Meta. All of these are very nice leading research blogs. And finally, what do you do after reading? You keep an active LinkedIn profile, just communicating your thoughts. And this does two things. It signals to your potential employer that you're active, right? You really care about the field. You're not just out there looking for a job. And the second thing it does is it, builds you as a thought leader in the space. And obviously, do not do end-to-end AI written LinkedIn posts. You can take help of AI, but it should always be a help. It should not just be AI. But reading and writing is not enough. You need to be a developer. So learn new tools and create cheat sheets for yourself to refer back to. Whenever you're in a classroom, you're learning something, make sure at the end of that class, you're creating a cheat sheet, right? Not only for the exam, if it's an open book exam, but also for yourself. And you don't need to remember everything. Participate in a few competitions that interest you just for doing some nice projects. And again, this is for getting you more interested and seeing how other people are solving the same problem and seeing how the winning solution actually looked like, let's say in Kaggle or Analytics Vidya, and there are a lot of other competitions which are going on. And with all of this, what do? You have to create a GitHub profile that demonstrates the project repos. You need to focus on reproducible, cleanly written modular Python code, right? And I think I'll need to take 10 minutes from now to complete all of it. So we might extend this presentation by a bit. But yeah, reproducible means that your code needs to be running and producing the same results on different laptops, right? It needs to be reproducible. It needs to be cleanly written, right? Jupyter Notebook, one large Jupyter Notebook, right? One data file pushed through GitHub, not done, right? You need to write the code clearly with sections, with comments, with doc strings, and make it modular, right? So it's good to have a Python notebook. It shows that a Python notebook that you experimented, but eventually it needs to be scripts put into proper folders. And why is this actually needed? Because to get a job, you need to show that you're ready for the job, right? You will not just work in Jupyter Notebooks, because remember, at a job, the goal is to put things in production. And production ready code means Python scripts, modular, cleanly written, well commented out scripts. That's why this is important. This prepares you for the job. And this is a snapshot of how my GitHub profile looked. This is my github.io website. And I had actually this from 2017, right? Way back when I was a master's student in the US. And I did some projects and I put it here just to give you a sense what I did. This was with the first one was with D3.js, a visualization as part of a visualization class. This was a Kaggle competition, which I participated in. Similarly, this one is a Kaggle competition. One of this was a McKinsey hackathon. One of this is an R, right? So the bottom write two things are done R programming, right? So it shows diversity, that not only Python, you also know R, you also have participated in Kaggle. And then once you click on these, you will see a page which reports these out with the code as well. Okay. So now that, let's say you have done classroom learning, you have actually learned a lot, right? And you're ready for your placements. Now there are two things what you need to do to get your foot into the door, right? The first thing is your foot needs to be prepared, right? And the second thing is that the door you're trying to open is the right door. So the first thing is obviously to put your best foot forward. How do you present yourself on your resume, right? Now, this is very, very important. Why? Because the employer is seeing your resume. That's it. He does not know you. He does not know your intelligence, your expertise, and so on. So how do you build your resume? The order should be pretty much like this. And it should be a one-pager, right? Education, short section, let's say 20%. Experience, depending on how much you actually can show. And I'm talking about relevant experience for the most part, which can be, analytical experience, which can be proper AI experience if you have some, or it can also be some industry projects that you have done. And how this is good and why I want to put this here is because in Geo Institute's PGP program, you do an internship. And by the end of that internship, you do have a set of nice bullet points that you can put on before the official placement starts. And this is something similar to what I did in San Francisco back in 2017, where I had a 9-month, part-time kind of a project undertaking with an employer. And whereas at Geo, it is a fully 2-month, almost 2-month, internship, fully focused. So this is very, very nice to put in your resume. Skills and certifications. I would argue skills are more important. Certifications, you definitely do need one or two. And I'll clarify this in the next slide. Co-curriculars and extracurriculars. Co-curriculars means, even you can put things like you're active on Stack Overflow, you are commenting out, you have done Kaggle competitions, not a good rank, but you have actually put your notebooks on Kaggle kernels and, people have liked it. Even that can be reported out as a co-curricular. So it does not just need to be that, okay, I need to win the competition. Whatever you're doing, right, you can actually mention it in a nice way there. And extracurriculars should be very, very minimal, typically. Unless it's a leadership role, which is not in an AI setting when you're starting out entry level. Use the star method to structure each bullet point, right? So I've seen a lot of resumes with non-structured bullet points. That's very important. What was the situation? What was the task you were assigned? What did you do and what was the result? And keep a lot of focus on the technical side, right? This is another place where people falter is they just, tell that, okay, my business saw $1 million improvement, in the bottom line, and that's it. They do not tell, okay, I used a random forest model, I tuned it iteratively, I was able to tune these particular parameters, right? And I was able to achieve this particular accuracy in the case of classification, right? I looked at these particular metrics because these metrics made sense. So all of that thought process which went around building the AI needs to be there on your resume, right? Any unique things you did and quantifiable business outcomes also need to be there ideally. Even if it is not there, even if the business outcome is not there, as long as you're able to achieve, focus on the AI techniques, that's also good, right? Because business outcomes are not always in your hand, and that's understandable. Now, some pro tips from my side, right? In addition to this, try to keep a diverse set of personal projects. This is another question I get, like, what should I actually do, right? Unless the role is very specific that you're targeting. Typically, a good benchmark is to do ML, regression classification, like one project each. You can do time series analysis, GenAI, DL, right? Either, let's say 2 out of these, right? So 2 + 2, 4 projects, and then 1 in MLOps, or you can combine MLOps in all of these, right? So 4 projects overall, if you're able to do. And keep your resume strictly one pager, right? You do not need photos always. You do not need like nice things. It needs to be very professional, one pager. And if you have 10+ years experience, 2 pages are good. And it should be readable and customized to the job description, ideally, right? Because job descriptions are very specific again. And the way you go about it is you create a master resume first. So you do not start with just taking the one page and putting things down. First, put down everything you have done in your life, right? Starting from your school, college, whatever you have done, and then filter it out and think about what should go into that one pager. The second step is aim for the right door. Okay, so how should you apply for jobs? Simply put, there are a lot of roles available in the AI/ML field which slightly differ, and you need to be able to understand what are the roles. So data analyst is basically about, like, let's think about SQL, writing code, right? SQL code to examine the data, doing visualizations and just analyzing the data. Data scientist is going one step forward, using predictive models based on the data to solve complex problems. Research scientist is doing a little bit deeper on the research side, so developing new algorithms, going to research papers, and then publishing research. And then a role called applied scientist, which is somewhat analogous to data scientist, right? But it is a little bit on the more technology side. So Amazon has applied scientists. Why? Because they have teams developing Amazon Alexa, right? They have teams developing, if you think about the Amazon, the packages that you get from Amazon, right? That's operations research. They need a maps team, which identifies the smallest route and the optimal time taken to reach the customer. So their challenges are not always with regard to data. There are a lot of tech-oriented challenges, which is where applied scientist role is very, very important. You need to know a lot of algorithms and depth of that. And that's actually what my role is also. I'm a principal applied scientist in generative AI, because I'm not developing GenAI LLMs from scratch with data, right? I am building thought leadership around GenAI engineering itself to build applications, right? So that's an applied scientist role. Then you have a GenAI scientist role, which is again specifically for GenAI. You have AI/ML engineer, which typically are dealing with deploying and maintaining models in production and scaling ML systems, right? So taking a prototype and how do you scale it, building the engineering aspects around it. You have data engineer, which is specifically for data engineering, right? So building scalable data infrastructure and pipelines. How do you pre-process data? How do you get data from a certain format to another format? How do you stream data? And the field of big data eventually. And then AI consultants, which is slightly less technical, a little bit more on the client side. You need to be able to interface with clients. So all of these are in the field of AI/ML, but you need to read the title and also read the job description of the role very carefully. Because sometimes what happens is AI/ML engineers is mentioned as the title, but the description is given, let's say, of a data scientist, right? Or any other combination. And the second thing is you need to understand what AI use cases are of interest to the company. And this will help you write better cover letters. Now, let me go over certain certifications, right? And these are industry recognized skills and certifications. And with certifications, they are mainly for signaling. You do not need always a certification from a course. You can do a course without a certification. And the caveat is you can still feature it on your resume and it counts to the employer, right? So the employer does not care, right? A good employer will never care that, okay, you have done 10 certifications, 20, because certifications are just signaling, right? Even if you have done free courses, and I will talk about some of these, right? So for example, the Stanford series on language modeling is on YouTube. And if you put that, okay, I did this, I did the exercises, and I was able to do it, the interviewer will be impressed, right? You need to demonstrate your skills, obviously, but that also counts, right? Similarly, you have Harvard CS50, which is introduction to Python, right? Programming. You have LangChain Academy, which is specific for LangChain. Similarly, you have Snowflake Academy, Databricks Academy. Very industry tool specific academies are out there, which help you learn tools from the makers. And deep learning AI is another good one. And these are video-based courses. Another one that I can recommend for MLOps specifically is again free. It's made with ML. It's a website by Anyscale. And then you obviously can do some cloud certifications. One of my one which I have done is ML specialty, but there are again foundational ones also that you can do, which can show you and which can put you apart in your resume. Now, how do you skill up for the interview? Now, the basic thing that you need to understand is you need to present yourself as first day job ready, that the employer sees you as, okay, this person can just come in and do my project in a good time, right? And that basically gets you the job. What this means is fundamentals, obviously. Break your projects apart, think about why you did certain things and how are things working, how is the algorithm working, and also a lot of system thinking, right? What I mean by system thinking is you need to look at it from an overall perspective, that where will the data come from? How will I ingest it into my models? How will I do feature engineering? How will I do the modeling? And then how will I create an API endpoint out of that? How will I do model serving? And how will I monitor it in production, right? And think about latency, cost, and all of these trade-offs, right? So you need to also be able to reason out and do some system thinking, because given a problem statement, as a data scientist or any other AI/ML engineer, you need to be able to think about what are the different steps involved and give certain cost estimates to your leaders, right? And there will be application SLAs where latency will be important. MLOps all the way. MLOps is very, very important, which will set you apart, right? Which people are looking for in the industry. You should be able to deploy fast API endpoints, which, some platforms perform CI/CD and go deep, like we discussed, right? Take one specialization, go deep into it, at least. Instead of trying to cover everything, because it's a unicorn field. You will not be able to do everything in the specialization area. Build communication. You should be able to articulate what the problem meant, right? How you solved it, and defend those choices, right, that you took. So interview can come in with an attacking mindset and say, okay, you did this. Should you not have done that, right? Should you not have done some other thing? Or why did you do this? So even in an interview, it matters. And at job, obviously, it matters because you have a lot of people to explain why you're doing what you're doing. Pro tip, be a problem identifier. Identify what problem you can solve, right, in the company that you're applying to, right, or what they have solved. Think about how would you solve that same problem, right, and critique your own solution and their solution if it is public, right? So just try to do these three things together, and this is how you can skill up for your interview. Even in your projects, you can do all of these three things, right? Whatever pet projects you have done, try to say, critique yourself, and you should have that as a statement. If the interviewer asks you what could you have done better, you should have that critique already ready. Now, last thing before I jump shortly to my journey and we close it, is tips to crack the interview. Now, if you've made it to the interview, your technical skills will be tested, your communication skills will be tested, and your critical thinking skills will be tested. Why critical thinking? Because you will not know everything. You will be given a very broad problem statement, right? And you will need to critically think like a consultant and break it down to a technical problem, solve the problem, and communicate it efficiently to the interviewer. How to prepare? And again, these are tips, right? So coding tests are typically the first stage, and these are very varied, right? So you think that, okay, I can do Python, I know ML, AI, and I'm good. But that's typically not the case, right? Because if you're looking at FANG companies, they ask you data structures and algorithms, because at FANG companies, AI is not just taking data sets and building random forests or some machine learning models or deep learning models. There it's a little bit or quite a bit more advanced, right? So the way these tech first or tech leaders look at AI versus the vast majority of, let's say, domain specific companies like healthcare companies, retail companies, right, financial companies, all of these are also doing AI. Automotive companies, how they look at AI is different. So if you're applying to FANG companies, DSA is a very strong, important topic, because there your role will be software engineer, AI/ML, right? So you are a software engineer specialized in AI/ML. You need to be familiar with DSA. Implementations of ML algorithms can come in, or something else, right? So check out and try to understand what that coding test would typically look like. You can also ask the recruiter if they can share that, or some other friend, or reach out, see what people are posting, and try to find this out. Next thing, the technical interview is a consulting session where you will need to think aloud and handle ambiguity well. So if a person is asking you a question and you are just not able to answer that or think aloud, that will be a bottleneck. Because on the job as a data scientist, what will happen is a product manager, right, who's just managing that entire delivery, will pull you in, and you will interface with a business team member, a business client, so to speak, right? And the business client will put forward their points, and if you are able to also think aloud and handle some of the thought process around that, it will really set you apart in the interview. So communication is important. And then culture fit is a vision and alignment, right? So for an AI role, what is a culture fit? It's not just tech, it's not just your aptitude. It's also, do you understand the company's business and where AI adds value to it? So that's where I was saying that you need to be able to think about the company's business as well, and think about that really critically, learn about it. Pro tips: prepare a story about an AI project that failed and what you learned, right? AI does not always work, right? Let me break the ice. You will fail, right? And that's perfectly normal, because AI is not easy. It is one of the more difficult fields out there. Although it's widespread, everyone is doing it, but not everyone is doing it to a good extent or good level of quality. So AI projects will fail, but you need to document your learnings as well. And similarly for behavioral interviews as well. And don't worry if you faltered in the interview, you're not expected to be a unicorn. So if you are specializing in time series and or some specific area and someone is asking you something else, you can just tell them your level of knowledge and you're good. But you should know what you are specializing in or what you have actually done on your resume very, very well. That will not be excused. Now, very quickly in 2 minutes, how did I do it? My non-linear journey. So I started doing school, right? Did not learn AI obviously there. Then went to IIT Kharagpur, and again, not much of AI there, right? But then when I came to the US and did my MS in computational science, this is where my advisor actually pushed me into machine learning, AI, and I took some nice courses out there. And a lot of that I see reflected, within some of the courses. And there are a few professors which are common within University of Minnesota and Geo Institute, which is Professor Arindam. He taught me, ML back there in 2017, and he's also teaching in Geo Institute. So Geo Institute has a very lot of nice faculty, and there are other programs obviously in India and abroad which have nice faculty. And then University of San Francisco is where I did an MS in data science and AI. The core courses is what I completed. Then I started out in industry, started out as a data scientist at 𝘠𝘬𝘀, which is an ad tech firm in San Francisco. Then directly joined as a lead data scientist at Nissan, right, where I was leading some project teams, building around forecasting and computer vision, NLP, and so on. So this was kind of my first, broad experience, how I saw the industry work. And that led to me a lot of thinking that, okay, I need to, be a little bit more in the business side, also understand the business scenarios. And this was my personal choice, obviously. You will shortly see why it was a personal choice, because I did not do anything, on the consulting side, although I got a job in Abu Dhabi, which is one of the more preferred destinations for people, obviously, in India. I came back to Nissan as a data science manager because I wanted to stay in tech, and tech is where the wave is going. So I started managing, technically data science teams and also interfacing with US teams and so on. And currently I'm a principal applied scientist at TrueFoundry, which is a startup which is specializing in generative AI. So we are building a generative AI platform, obviously for streamlining GenAI, right? And I'm a principal scientist here. And I've also basically done a bunch of things, been able to do this, spoken at Analytics Vidya's conferences in deep learning and generative AI. I'm also at faculty at Geo Institute, right? So taught very nice classes here. And also I'm featured on Spotify, and I've also judged the Global Enlighten Award as well. Right. So finally, my message is you can do it too. You can actually map your career from the classroom to the corporate. If you follow a lot of the tips that I gave you, it's a lot to follow. Even if you do, let's say 20% or 30% of it very consistently and with a very attentive mindset, you will be there, right? So it's not impossible. A lot of people are doing it. You just need to know what to do, and you need to follow through and actually do it properly and consistently. You can stay connected with me, and I'm open for questions now.
So we have a couple of questions here.
Sure.
First is, with AI evolving so rapidly and so many people entering the field, what do you believe will truly set apart the next generation for AI professionals, and which emerging skills or domains such as generative AI, ML ops, or AI ethics will be most critical in the next few years?
So the space is rapidly evolving. How it will happen is the areas which are very fundamental, those will never go away. Like think about machine learning algorithms, think about basics, fundamentals of neural networks, think about Python programming that will continue to evolve. That will not go away, but things which can be automated, right? A lot of the high level decision making or systems thinking around how should you do certain things. So AI or generative AI will be able to advise us and even automate some of that, writing the code. Because if you have read reports about vibe coding actually, takes you more time to implement than if you would have just sat down and written your code yourself. So a lot of it is definitely hype, and it will continue to mature in the next 10 years. And how it will happen is it will slowly percolate through everything. It will not be one boom that will come. Slowly, it will change the way we are working with AI. And obviously generative AI, ML ops, and responsible AI, these will continue to become more and more important, because if you look at AI now, at least in the last 3 years, generative AI is a very large portion of what companies are trying to do, right? I'm not saying they're able to do it properly, but they're at least trying to do, and it's becoming serious. They're becoming serious out there. And the traditional AI ML will not go out of fashion, because that's the bread and butter of companies. Think about sales forecasting, right? Sales is one of the cornerstone sales and marketing programs. Think about if you look at loan default prediction use case in financial company. Think about insurance companies. So all of these very use cases which are actually very fundamental will never go away. So even they will just continue to evolve over time. So you should just master the fundamentals and pick one area which you are seeing. Like generative AI is a nice area to be in, like learn how to build an agent and MCP servers, but do not forget the fundamental concepts.
Next question is, in your experience, what matters more for building a successful AI career? Theoretical depth or the ability to deliver practical, real-world solutions? And what are some less obvious mistakes aspirants should avoid in the interviews?
So what matters more? It depends as you're going through the life cycle of your career, right? So when you're starting out, if you know a lot of theory, right, if you know a lot of depth, but you're not able to implement it efficiently, you will lose out. So starting out, obviously know what you're doing, but be able to implement it very, very efficiently. That will set you apart. You will grow. As you're growing, you will figure out the implementations. They will be at the back of your hand. But then you need to, obviously, to improve the AI systems, you need to go deeper into the applied research or the science of it, that how are they working, how can you improve it. So the theoretical aspect really becomes important down the line as an AI system continues to evolve, and as you also continue to evolve in your career. For example, in my role, I have to do a lot of thinking around generative AI research that's going on at the cutting edge, right? So things which are just coming out 2 days before, I have to go see the person who developed it, talk about it on YouTube, and learn about it, and then basically translate it to what we can do with it. So the theory really becomes important. The depth of that theory, that level, becomes important as you mature down your career, and that will set you apart. But initially, you need to be very hands-on. And what was the second part, Meenal?
Second part is, what are some less obvious mistakes aspirants should avoid in the interviews?
So again, one thing is the fundamentals, the correlation question that I asked, right? Simple things like that should be avoided. You need to master your fundamentals very, very, particularly. If it is data structures, algorithms, that should be prepared. And the less obvious ones are the software engineering and the ML ops side of it, right? So the last row that I showed you on the tech stack page, you need to know Docker. That's typically a good setting apart. So basically what I mean is, you don't just need to know the tech of it. You also need to do systems thinking. That is typically missed out, right? How would you do it? Even if you have to learn how to use Docker, you should know that there is something like Docker out there, and this is how you would do it. So you need to be able to solutionize, come up with a solution, be a problem solver in the interview, basically, and think aloud. Yeah.
Okay. And the next question is, can we know which courses should I pursue for someone who has been working in the banking IT industry for 13 years?
So I'll break it down into two things. If you're looking for a part-time or something less, which takes a little bit less of your time because you already have that much of an experience, and if you're looking for something like a boot camp, so to speak, I would definitely encourage you to go through some of the openly available material out there, right, that I mentioned on the blogs. So definitely go through those. But programs like GeoInstitute's program, right, and other programs, there are other programs as well in India. You can also take a full-time course and actually learn AI. And similar to how I did with ISB, right? I did an MBA, but I'm not doing any core MBA, like traditional MBA thing, so to speak. You can also do a full-time PGP program, learn AI, and then go back to your core skill set and start applying AI there. And if you're talking about courses specifically, like let's say 1 or 2 courses, what you can learn is time series analysis is definitely a no-brainer. And Python is very, very much needed in financial and banking. So you need to know Python, statistics, ML. These would be my three, if you're talking about specific courses, these are the three picks that I would give you.
Okay. The next one is, what are the biggest technical challenges your team is facing right now?
Well, it's facing every kind of challenge because we are a startup, like we mentioned, and we are less than 100 people strong, and we already have a lot of funding, Series A funding, which came this year. So I would break it into two things, right? Challenges, there are lots. Things break every day, right? When we are talking to clients, things break, but the important part is we are able to fix it before the client expects it, right? So we have actually one client just because of other people were able to give the same product to the client in 2 months, set it up on their account, and we were able to do it in 1 week. So challenges will be there in AI because AI is evolving and it's difficult to do, and it's software basically, right? So it's a software plus AI. It's a mix of that too. It is difficult, but how quickly can you counter it, and how clear your thought process is, and how efficient you are with solving that problem is what's important.
Okay. The next question is, having fundamental knowledge, which you have shown in the PPT, can help us to get an internship or beginner level jobs?
Fundamental knowledge with implementation efficiency, and you're strong if you know how to implement. Even let's say I have had interns at my previous company where they just knew Python, they just knew ML, but they were able to pick up GenAI very quickly just because they knew Python so well. They looked at the generative AI LangChain documentation, they read through it in 3-4 days, they took some tutorials, and they were good to go, right? So 5 days on the job and you're good to go. That's pretty much good enough. So if you're able to, so again, the thing is not just how much should I know, it's basically how well do you know your fundamentals. And when you're starting out in an internship, hands-on is all you need to know, obviously with the very basics concepts, that because those will be rejection points otherwise if you don't know them.
We'll take one more last question. That is, what courses I should do? I've been doing CAD designing from last 4 years. What courses I can do?
So again, the general courses will be very important. So if you go back to the courses, let me just quickly go back here. Okay, I think it's a lot of going back, but here we are. So you're in CAD designing. If you're thinking to just generally pick up AI and be good at your job, right? Python again is a very, very important language. I cannot stress enough how important Python is. So you need to understand Python like any Python programmer would, right? Be a software engineer using Python, be it an AI engineer, data scientist, you need to know your Python well. Why? Because even in your domain, Python would have certain libraries that you can actually leverage for your use case, right? So that's a very basic. And if you're interested about machine learning, AI, right? I'm just thinking because you want to take some very high level courses. If that's the case, you can take Udemy courses on machine learning, right? Or even deep learning as well, but with a focus on implementation. So you do not need to go too much into the theory, but just be able to implement it, do a top bottom approach, implement, see the value, and then if you want to, you can go into the fundamentals. But I would say Python, machine learning, and then if you have the bandwidth, deep learning implementations would be very good to do.
Okay, thank you. So this comes to an end of the session. I believe all the questions are answered and you have got all the answers, candidates. Thank you so much, Professor Anant, for such an insightful session. And we look forward to all the candidates for the next session of the series.